Hello and welcome to this online math tutorial. Today I'm going to show you how to use the Pythagorean theorem to find the length of the hypotenuse in a right triangle. So first let's go over some of the terminology here. What is a right triangle? And also, what is a hypotenuse? Here's a right triangle, and what's unique about this triangle is that one of the angles here is 90 degrees. We know that this is the 90-degree angle here because of this little box in the corner. That tells us that it's a 90-degree or right angle, hence the term right triangle. Now let's figure out which of the three sides is our hypotenuse. I like to use this little trick where I use the square in the corner to draw an arrow. And that arrow is always pointing to the longest side of our triangle called the hypotenuse. So here is our hypotenuse. So let's see if we can figure out where our hypotenuse is in other triangles. Alright, so let's take a look at this red triangle. Again, we can use the little square in the corner here to draw an arrow, which points right at our hypotenuse on the opposite side. So here is our hypotenuse. How about in the blue triangle? Again, we can draw a little arrow here, which points right at our hypotenuse here. Now, why do you think we would ever want to know what the length of a hypotenuse is in a right triangle? Well, let's look at a real-world example. Here's a building with a ladder leaning up against it. Can you figure out where the right triangle is here? Let's draw it. So here's our right triangle. Again, it has the little box in the corner to show you that it's a 90-degree angle. And we can use that box to draw an arrow which points at the opposite side called the hypotenuse. So now I'm going to show you the Pythagorean theorem, which can help us find the length of this hypotenuse. So first let's identify where our hypotenuse is over here. Here's our arrow, and then here would be our hypotenuse. Now we're going to start to use the letter C for our hypotenuse. So I'm going to write the letter C over here. And then we'll use the letters A and B for our other two sides. So this side over here can be side A, and the other side can be side B. Now it doesn't matter which side is A and which side is B, as long as we choose our hypotenuse to be side C. Now I'm going to show you the Pythagorean theorem. A squared plus B squared equals C squared. Let's do an example. Side A is 4 centimeters long, and side B is 3 centimeters long. How are we going to use this information in the Pythagorean theorem to find the length of the hypotenuse, side C? Well, let's write out the Pythagorean theorem again. A squared plus B squared equals C squared. Now let's substitute all the values in. A is 4 centimeters, so let's plug in 4 for A. So we have 4 squared plus, and B is 3 centimeters, so let's plug in 3 for B. 4 squared plus 3 squared equals C squared. Now let's simplify the left side of the equation. 4 squared is the same thing as 4 times 4, which is 16, plus 3 squared, which is 3 times 3, which is 9, equals C squared. Now let's add up the terms on the left side. 16 plus 9 is 25, equals C squared. Now we're not looking to find the value of C squared, we want the value of C. So we need to get rid of this little squared symbol here. And to do that, we take the square root of both sides. So when we take the square root of C squared, we get C. And now how do we take the square root of 25? Well, that just means what number multiplies by itself to give you 25. That would be 5. 5 times 5 is 25. Therefore, side C is equal to 5. Since all the other sides have units of centimeters, we know that C is 5 centimeters long. So let's write our concluding statement. Therefore, side C is equal to 5 centimeters. I hope you enjoyed this lesson. Thanks for watching. Bye.